This video, we will understand about trees and different terminologies in trees. Definition: a graph capital G is called a tree if G is connected and contains no cycle. From the above definition, it is clear that a tree is connected and has neither self loops nor parallel edges and is denoted by the symbol capital T. Trees may be directed or non-directed. So next, forest. What do we mean by forest? If graphs containing no cycle that are not connected are called forests and have the property that each of their connected components is a tree. A forest is a set of disjoint trees. See, this is a tree where we may notice that there is no cycle, but it is connected. This is not a tree because there is a cycle here. And this is a forest because this is considered to be one tree. This is considered to be another tree. Bunch of trees. So you call it as a forest. Theorem: an undirected graph is a tree if and only if there is a unique simple path between any two of its vertices. What do we mean by a rooted tree? A rooted tree is a tree in which one vertex has been designated as the root and every edge is directed away from the root. A rooted tree is a finite set of one or more vertices such that there is a designated vertex called the root and the remaining vertices are partitioned into n disjoint sets, that is T1, T2 and so on up to Tn, where each of them are called subtrees of the root. The incoming degree of the root is 0 and the incoming degree of all other vertices are 1. In a rooted tree, a vertex whose outgoing degree is 0 is called a leaf node or a terminal node, and a vertex whose outgoing degree is non-zero is called branch node or internal node. Family trees are also rooted trees. So let us understand this concept with an example, with a diagram. This is the root. This entire thing, we call it as capital T, a tree. This is the root of the tree and it has got two branches, this B and this D. And this entire bunch is considered to be T1, tree 1, subtree. This is another subtree T2. This is third subtree T3. And it goes like this: A and here B and here D and here C. And from B there are two branches, E and F. Again from F there are two branches, K and L. From C there is only one branch, which is G. From D there are three branches, H, I, J. So this K, L, G are called leaf nodes. This K, L, G, and even these are H, I, J is also a leaf node. Terminologies: root, a vertex that does not have a parent. See here, this do not have any parent is termed as the root. I mean, there is nothing before this. That is why you call them as a parent. In the above sample tree, A is the root and vertices B, C, D are the children. B, C, D are the children of the root. Hence, vertex A is the parent of B, C, and D. Then predecessor. Each vertex V in a tree except root has a unique parent called a predecessor of V. In the above example, B is the predecessor of E, F, K, and L. E, F, K, and L. B is the predecessor. Then parent. Parent is the immediate predecessor of a vertex. In the above, B is the parent of E and F. Parent of E and F. And C is the parent of G. C is the parent of G. And I can also say D is the parent of H, I, J. Successor. Every vertex in a tree except the leaf has a unique child called a successor. In the above, E, F, K, and L are the successors of B. E, F, K, and L are all successors of B. Child. In the above, E is a child of B and C is a child of A. We may notice E is a child of B. Yes, E is a child of B and B is a child of A. And I is a child of D. I is a child of D. Yeah. Siblings. Vertices with the same parent are called siblings. In the above, B, C, and D are siblings. B, C, D are all siblings because they have a common parent A. Ancestor. The ancestors of a vertex other than the root or the vertices in the path from the root to that vertex, excluding the vertex itself and including the root. In the above, B is the ancestor of E, F, K, and L. B is the ancestor of E, F, K, and L. Similarly, D is the ancestor of H, I, J. Descendant. The descendants of a vertex V are those vertices that have V as an ancestor. The descendants of B are E, F, K, and L. Descendants of B are E, F, K, and L. Descendants can also be called as successors, right? Both are same. Leaf. A vertex of a rooted tree is called a leaf if it has no children. It will have an out degree 0. In the above, E, K, L, G, H, I, J are all leaves. See, E, there is no child for it. K, L, there is no child. G, there is no child. H, I, J, there is no child for them. Internal vertices. Vertices that have both parent and children are internal vertices. In the above, B, F, C, and D are internal vertices. We may notice B as a parent and also children, C as a parent as well as children, D has a parent and also children. So these are called as internal vertices. Subtree. In the above, T1, T2, T3 are subtrees. We already saw that. This is a subtree, this is a subtree, this is a subtree. Degree. The maximum number of children that is possible for a vertex is known as the degree of the vertex. The number of subtrees of the root of the tree is called the degree of the tree. In the above, degree of A is 3 because 1, 2, 3. That is why it is 3. And degree of B is 2, 1 and 2. And degree of D is 3 and H it is 0. D it is 3, H there is no children for it, so that is 0. In degree and out degree. The number of edges entering into the vertex is known as the in degree, and the number of edges coming out of the vertex is known as an out degree. In the above, the in degree of root is 0 because there is nothing coming to that, whereas out degree it is going to A, B, C, so it is 3. The in degree of vertex B is 1 and its out degree is 3. B is 1, out degree it is 2. Level. Level is the rank of hierarchy. Root node is termed as in level 0. Similarly, each vertex in a tree has a level. The vertices with the same level number are said to belong to the same generation. In the above, level of B, C, D are at level 1. We may notice it will all be parallel, B, C, D. And then E, F, H, I, J, that is level 2. Then K, L, G or level 3. And root is level 0. Then edge, the line drawn from one vertex to another vertex is called edge. In the above, number of edges is 8. The line from A to B, A to C, etc. are called edges. We already saw that, the lines. Path, the sequence of consecutive edges is called a path. In the above, the path from A to L is A, B, F, and L. And the length of this path is 4, A to L. A to L, A to B, B to F, F to L. Depth or height, it is the maximum number of vertices that is possible in a path starting from root node to a leaf node. The maximum level of any leaf in the tree can be considered as the height. In the above, the longest path is ABFK or ABFL. Hence, the height or depth of the tree is 3 here. So these are some of the terminologies in a